Hello. Uh, Today we are going to uh, discuss one important problem, that is charged oscillator in an electric field. Okay, charged oscillator in an electric field. This problem is important. For example, a particle of a charge q and mass of the charge is m, which is moving in a one-dimensional harmonic potential of a frequency omega. Now I am going to subject this charged particle uh, to a weak electric field. To a weak electric field. It is denoted by like this, small e. Okay. So here we are going to find two objectives. One is find the exact expression for energy. First objective is find the exact expression for energy. Second object is calculate the energy to first non-zero correction and compare it with the exact resultant values. Okay. Second object is calculate the energy to first non-zero correction, non-zero correction. Okay, they're mentioning here non-zero connection and compare it with the exact result obtained object 1 and object A. So here the Hamiltonian is split into two terms. One is unperturbed Hamiltonian, another one is perturbed Hamiltonian. So here I am going to write uh, Hamiltonian of the system. So if you look at this statement here, the oscillator, charged oscillator, charged oscillator in an electric field. So one charge is there, the particle of mass of the charge is m. It has some frequency angular frequency omega, and this charged particle I'm going to subject it into a weak electric field. Then the potential energy might change, right? So potential energy is different. So therefore, the potential energy of the system I'm going to write like this: the total Hamiltonian of this system, that p square divided by 2m plus, since we are discussing quantum mechanics, it is better to use operators. In place of p square, I'm going to use the operator, okay? Minus h cross square divided by 2m d square divided by dx square. This is potential energy plus a kinetic energy. This is m omega square x square. So this is harmonic oscillator energy, right? So extra term, this charged particle is subjected into the external electric field. For that, uh, it create extra potential charge. Okay, electric charge, in charge. This is electric field. Okay, it displays into the one dimensional, right? So we are considering here the only one dimensional. Okay, so this is the exact Hamiltonian of the system, given system. So this is unperturbed term. This is the perturbed term. Very, very important. Perturbed term. We need to solve this problem. So we need to find the what is the exact energy level of this system. Okay, we know up to these values, the kinetic and potential energy. We know this energy is E is equal to n plus 1 divided by 2 h cross omega. So here one extra term is said, that is a because of electric field generate this extra potential q e into x, right? We need to find what is the exact value of this potential unperturbed, sorry, perturbed potential term. So here I'm going to assume one equation and define y equal to like this: x plus q electric field divided by m omega squared. This is completely assumption value. Okay. So by using this assumption, I'm going to write x equal to like this: x equal to y minus q electric field divided by m omega squared. So now substitute this x value, x value uh, here. Okay, then you can get the exact Hamiltonian of the system. Exact Hamiltonian of the system. So here I'm using y, right, which is why I'm going to use in place of x y. Hamiltonian h equal to minus h cross square divided by 2m d square divided by dy square plus 1 divided by 2 m omega square y square minus q square electric field square divided by 2m omega square. This is the exact uh, Hamiltonian of the system. So the eigenvalue of this Hamiltonian is, eigen energy for above equation, this equation. So this is what the first object, right? So energy En equal to n plus 1 divided by 2 h cross omega minus q square e square divided by 2m omega square. This is the electric field. Okay. So it is better to write small e. Okay, this is going to confusion, which is why I'm using this one. Okay, no problem. I'm going to use like this e. So this is the exact energy of the system, given system. Okay, this is the first object. The second object is they are asking calculate the non-zero correction energy terms. Why they are asking non-zero correction term? Because here the potential energy is perturbed potential energy QEX, right? If you look at the second object B, first order correction to the energy. So first order correction to the energy formula, ground state H suffix P into ground state, right? So we need to substitute perturbed Hamiltonian. What is the perturbed Hamiltonian? Here in the system Q electric field into X. So try to substitute perturbation value here. After substituting perturbation value Q electric field, okay, it is better to write like this. Electric field into X ground state energy. Charge and electric field E I am going to write outside. It will not affect the position of the system. So therefore I got this. So what is the corrected energy of the system? So we already discussed this type of problem. Potential energy of Bx, just wait, I am show you. Here it is there already. See, potential energy of Bx. So we already calculate all these things. Previous class, please go and watch the previous things. For all odd parity functions, the first order correction energy is 0. This is the proof. See here, Bx is there. Since that B is constant like charge and electric field, that is constant. Okay, use in place of x this value, then they try to follow these steps, then you can get first order correction energy is 0. Therefore, uh, here I got the first order correction energy is 0. Okay. Here I got first order correction and total energy is 0. So they are asking non-zero correction terms. So, but second order correction is not 0, maybe. So we need to calculate second order correction energy. So this is the first order correction energy is 0. So now I am going to calculate second order correction. They are asking, since they are asking non-zero corrected term, right? So which is why I'm going to second order correction energy. But the second order correction is not, maybe is not zero. So let us try to look. The formula of second order correction energy. So if you want to exact second order correction energy, this is the formula. Okay, m not equal to n m h suffix p n modulus square divided by en minus em. So this is the second order correction energy formula. If you don't know this formula, how to generate this formula, uh, starting class are there, maybe one class number 1, class number 2. Please go and watch the class number 1 and 2, then you can understand how we got this equation. So if you try to substitute perturbation energy here, then you can simplify this equation. This is x, okay, en2 second order correction energy term, summation m not equal to n m q e electric field into x n modulus square divided by e n minus e m. So this q and e are constant. I'm going to write this square, right? Q square electric field square, then summation m not equal to n. Remaining term is like this, m, okay, x n modulus square divided by, this is not x, here square is there. So we know already what is the position operator in terms of annihilation and creation operator. Position operator is h cross divided by 2m omega whole power 1 divided by 2 a diagonal plus a. And here I'm going to use two conditions. One is n plus 1 x n is not equal to 0 and n minus 1 x n is not equal to 0. So remaining all relations will be 0. So except these two. Okay. So this is the big question mark here. Why I am using these conditions and remaining all these things. Okay. We will discuss later. So this is where after substituting all the conditions here, only possible conditions are non-vanishing terms or these two terms only. Okay. So therefore, I'm going to check these two values. First one is n plus 1. In place of x, I'm going to use this equation divided by 2m omega whole power 1 divided by 2 A dagger plus A into N. So from this we can write this equation like this, whole power 1 divided by 2, then remaining N plus 1 A dagger plus A into N. So we already know how to calculate this type of equations because we discussed a lot of things, this type of equations, right? Then we try to rearrange this equation, n plus 1 into A dagger n plus n plus 1 into A n. So use these two formulas. One is if you apply A dagger on this n state, then you can get n plus 1 state into root n plus 1. This is one formula. Another formula, in case if you apply annihilation operator n state of the system, then you can get n minus 1 state will decrease one state. By using these two formulas, I'm going to apply exact formulas here. A dagger in place of A dagger on applying on n state. What you can get? H cross divided by 2m omega whole power 1 divided by 2. Uh, this is the first thing. Root is there. Formula after applying formula root n plus 1. The remaining equation is n plus 1, n plus 1. Okay, this is the formula, right? Exact formula. Plus this is the n plus 1. So in case if you apply the n plus 1 here, if you try to apply this one, so what you get clear? Root n, right? N plus 1, n plus 1 into n minus 1, right? N minus 1 state. So this is 0. So because these two states are different, right? This is going to be 0. Then only one term is remaining is there, h cross divided by 2m omega whole power 1 divided by 2 into, this is 1, right? Root n plus 1. So therefore, I'm using n plus 1 operation x into n root n plus 1 h cross divided by 2m omega whole power 1 divided by 2. Just wait. Okay, sorry for the delay. So this is equation number 1. A similar operation I'm going to apply here. N minus 1, n minus 1, n minus 1, x n equal to h cross h cross divided by Vm omega whole power 1 divided by 2 n minus 1 a dagger plus a into n. So h cross divided by 2m omega whole power 1 divided by 2. So this will I'm going to split n minus 1 a dagger n plus n minus 1 a. So this term is going to be 0, right? H cross divided by 2m omega whole power 1 divided by 2. So if you apply a dagger on the n state, then you can get root n plus 1 into n minus 1 n plus 1, right? Here root n minus 1 n minus 1. Directly I apply here the formula. Okay, so this is going to be 0 because this is n minus 1 state, this is n plus 1 state, this is going to be 1. So therefore here I got the result n minus 1 x n. If I apply this operation, root n h cross divided by 2m omega whole power 1 divided by 2. This is equation number 2. Sorry. Okay, this is equation number 2. So why I am calculating these two terms? If you clearly observe here, the only two remaining operations are the non-zero terms here after extending these x square terms. Okay, one is n plus 1 state, n minus 1 state. The remaining all will be 0. So after substituting this two equation number 1 and 2 in second order correction energy terms, then we can get answer easily. This question is asked by many national examinations. So this is the formula, right? E2 second order correction energy term Q square electric field square summation m not equal to n m x n modulus square divided by en power 0 minus em power 0. So only two terms, right? Q square E square. Now you can understand these terms why I am going to split this equation is like this. One is n plus 1 state x n modulus square divided by En power 0 minus En plus 1 power 0 plus n minus 1 x divided by En power 0 minus En minus 1 0 modulus square. So we already calculate these values, right? Try to substitute these values, then you can simplify, you can get answer. So one more information here. The energy difference between the two energy levels is h cross omega, right? N minus 1 state here, h cross omega, En power 0 minus En plus 1 power 0 equal to minus h cross omega. So now I'm going to simplify this equation. U square electric field square. So n plus 1 x n, maybe the first term, root n plus 1 h cross divided by 2m omega. Here square is there, square is going to cancel. The remaining equation is n plus 1 h cross divided by 2m omega. This energy difference is En power 0 minus En plus 1 is minus h cross omega. Plus here also root n, right? N into h cross divided by 2m omega. So this value we already calculate equation number 2. This is see here n minus 1 x n, equation number 2. So because here square is modulus square is there, right? Which is why I am not using the square. Okay, square is cancel, right? Divided by this energy difference is h cross omega. At equal to q square is the electric field, n plus 1 is 1 divided by 2m omega square, right? 2m h cross is going to cancel. So minus, if I multiply both sides here, only this term minus, the minus minus going to cancel. Here we can get minus. Then this is n divided by h cross going to cancel 2m omega square, right? Okay, the minus is there here. So because I multiply minus, right? So if you take minus here, so then you can get here the minus. So, okay, right. Minus q square electric field, this one electric field term. So I'm going to split n plus 1 term also. N plus 1 divided by 2, right? So first I'm going to write this term 2m omega square plus n divided by 2m omega square minus n divided by 2m omega square. So these two terms are cancelled. Remaining term is minus q square. This is the electric field term, okay, into 1 divided by 2m omega square. So this is the extra term, but minus q square electric field square divided by 2m omega square. This is the second order correction energy. Now it is easy to find correction energy, right? So the conclusion of this topic is the result of this problem. Corrected energy is En equal to En power 0 plus En power 1 plus En power 2. The first order correction energy, first order correction energy is 0. So we know already this harmonic oscillator energy. This better right here. So what is the harmonic oscillator energy? N plus 1 divided by 2 h cross omega plus 0 plus second order correction energy minus q square e square divided by 2m omega square. So this is very important problem for CSIR gate net examination. N plus 1 divided by 2 h cross omega minus q square electric field square divided by 2m omega square. This is the exact, not a not 100% exact value. So this is closely related to the almost corrected energy. Okay, exact value of the energy. If you look at the starting here, what they are asking, they're asking to find out the exact expression for the energy. Second is calculate the energy to the first non-zero correction. First non-zero correction, which is why I'm calculating the second order correction energy also. In case first order energy is going to be 0, then you need to calculate second order energy term. CSIR NET gate exam, they specifically mentioned is what? Calculate first order non-zero correction energy terms. Okay. So this is all about uh, charged oscillator in an electric field. Okay. Thank you.